Hi everyone, in this video I will show how to run our proposed ensemble method implementation to quantify uncertainty. The ensemble is used to calculate uncertainty for the prediction of any subject. We use Conda as a package manager. I will show how to install and set up Conda environment. We mainly use PyTorch and PyTorch Geometric in our project. First, I will show you how to install related packages. Then we will be running our code. In this tab, you will download the Anaconda from the following website. Please download the latest Python 3 version for your system. In our project, we have downloaded Python 3.8 version for 64-bit Windows. Create a Conda environment by typing the following command. Use the following command to activate your environment. Use pip to install NumPy, matplotlib, scikit-learn, and pandas. To install PyTorch, we need to install PyTorch, Torch Vision, and Torch Audio packages. Install PyTorch Geometry using these commands. PyTorch Geometry commands might be changed according to your system. Check out the PyTorch Geometry documentation if you will have a problem during installation. Then go to the GitHub link and download our code. Our framework takes brain connectome graph as input. After data is read, we parse the models in ensemble.txt and configure our ensemble as in config.py file. Then we provide the connectome graphs as input to our ensemble model to train. The ensemble outputs predictive IQ score and uncertainty score for each subject and saves them to results file path in config file as pickle object. Here is the file execution steps. First, we need to activate the environment that you install packages. Next, we need to create input file with the following command. Then data is successfully generated. And we are going to use this data. Before you start, make sure you have changed ensemble.txt file according to what you wish. In this example, I am going to use the file ensemble. And finally, we need to make a prediction from created input file. Mode argument refers to training with cross-validation or domain shift. At the end, you are going to see the plot for the error matrix. Feel free to save it. In this example, we use cross-validation with one seed and trained with one seed so that the training process is fast. Please refer to documentation in our GitHub repository. Thanks.